3.4 Tests for divisibility of numbers. Is the number 38 divisible by 2, by 4, by 5? By actually dividing 38 by these numbers, we find that it is divisible by 2, but not by 4 and 5. Let us see whether we can find a pattern that can tell us whether a number is divisible by 2, 3, 4, 5, 6, 8, 9, 10 or 11. Do you think such patterns can be easily seen? Divisibility by 10. Charu was looking at the multiples of 10. The multiples are 10, 20, 30, 40, 50, 60, and so on. She found something common in these numbers. Can you tell what? Each of these numbers has 0 in the ones place. She thought of some more numbers with 0 at ones place, like 100, 1000, 3200, 7010. She also found that all such numbers are divisible by 10. She finds that if a number has 0 in the ones place, then it is divisible by 10. Can you find out the divisibility rule for 100? Divisibility by 5. Money found some interesting pattern in the numbers 5, 10, 15, 20, 25, 30, 35, and so on. Can you tell the pattern? Look at the units place. All these numbers have either 0 or 5 in their ones place. We know that these numbers are divisible by 5. Money took up some more numbers that are divisible by 5, like 105, 215, 6205, 3500. Again, these numbers have either 0 or 5 in their ones places. He tried to divide the numbers 23, 56, 97 by 5. Will he be able to do that? Check it. He observes that a number which has either 0 or 5 in its ones place is divisible by 5. Other numbers leave a remainder. Is 1750125 divisible by 5? Divisibility by 2. Charu observes a few multiples of 2 to be 10, 12, 14, 16, and so on, and also numbers like 2410, 4356, 1358, 2972, 5974. She finds some pattern in the ones place of these numbers. Can you tell that? Page 55. These numbers have only the digits 0, 2, 4, 6, 8 in the ones place. She divides these numbers by 2 and gets remainder 0. She also finds that the numbers 2467, 4829 are not divisible by 2. These numbers do not have 0, 2, 4, 6 or 8 in their ones place. Looking at these observations, she concludes that a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. Divisibility by 3. Are the numbers 21, 27, 36, 54, 219 divisible by 3? Yes, they are. Are the numbers 25, 37, 260 divisible by 3? No. Can you see any pattern in the ones place? We cannot, because numbers with the same digit in the ones place can be divisible by 3, like 27, or may not be divisible by 3, like 17, 37. Let us now try to add the digits of 21, 36, 54 and 219. Do you observe anything special? 2 plus 1 is equal to 3, 3 plus 6 is equal to 9, 5 plus 4 is equal to 9, 2 plus 1 plus 9 is equal to 12. All these additions are divisible by 3. Add the digits in 25, 37, 260. We get 2 plus 5 is equal to 7, 3 plus 7 is equal to 10, 2 plus 6 plus 0 is equal to 8. These are not divisible by 3. We say that if the sum of the digits is a multiple of 3, then the number is divisible by 3. Is 7,221 divisible by 3? Divisibility by 6. Can you identify a number which is divisible by both 2 and 3? One such number is 18. Will 18 be divisible by 2 multiplied by 3 is equal to 6? Yes, it is. Find some more numbers like 18 and check if they are divisible by 6 also. Can you quickly think of a number which is divisible by 2 but not by 3? Now, for a number divisible by 3 but not by 2, one example is 27. Is 27 divisible by 6? No. Try to find numbers like 27. From these observations, we conclude that if a number is divisible by 2 and 3 both, then it is divisible by 6 also. Divisibility by 4. Can you quickly give 5 three-digit numbers divisible by 4? One such number is 212. Think of such four-digit numbers. One example is 1936. Observe the number formed by the ones and tens places of 212. It is 12, which is divisible by 4. For 1936, it is 36, again divisible by 4. Try the exercise with other such numbers, for example with 4612, 3516, 9532. Is the number 286 divisible by 4? No. Is 86 divisible by 4? No. So we see that a number with 3 or more digits is divisible by 4 if the number formed by its last 2 digits, that is ones and tens, is divisible by 4. Page 56. Check this rule by taking 10 more examples. Divisibility for 1 or 2 digit numbers by 4 has to be checked by actual division. Divisibility by 8. Are the numbers 1000, 2104, 1416 divisible by 8? You can check that they are divisible by 8. Let us try to see the pattern. Look at the digits at ones, tens and hundreds place of these numbers. These are 000, 104 and 416 respectively. These two are divisible by 8. Find some more numbers in which the number formed by the digits at units, tens and hundreds place, that is, last 3 digits, is divisible by 8. For example, 9216, 8216, 7216, 10,216, 99,95,216, etc. You will find that the numbers themselves are divisible by 8. We find that a number with 4 or more digits is divisible by 8 if the number formed by the last 3 digits is divisible by 8. Is 73,512 divisible by 8? The divisibility for numbers with 1, 2 or 3 digits by 8 has to be checked by actual division. Divisibility by 9. The multiples of 9 are 9, 18, 27, 36, 45, 54, and so on. There are other numbers like 4608, 5283 that are also divisible by 9. Do you find any pattern when the digits of these numbers are added? One plus 8 is equal to 9. 2 plus 7 is equal to 9. 3 plus 6 is equal to 9. 4 plus 5 is equal to 9. 4 plus 6 plus 0 plus 8 is equal to 18. 5 plus 2 plus 8 plus 3 is equal to 18. All these sums are also divisible by 9. Is the number 758 divisible by 9? No. The sum of its digits 7 plus 5 plus 8 is equal to 20. Is also not divisible by 9. These observations lead us to say that if the sum of the digits of a number is divisible by 9, then the number itself is divisible by 9. Divisibility by 11. The numbers 308, 1331 and 61,809 are all divisible by 11. We form a table and see if the digits in these numbers lead us to some pattern. We have a table with 4 columns. Column 1 says number. Column 2 says sum of the digits at odd places from the right. Column 3 says sum of the digits at even places from the right. And column 4 says difference. Number 308. Sum of the digits at odd places from the right. 8 plus 3 is equal to 11. Sum of the digits at even places from the right. 0. Difference. 11 minus 0 is equal to 11. We observe that in each case the difference is either 0 or divisible by 11. All these numbers are also divisible by 11. For the number 5081, the difference of the digits is 5 plus 8 minus 1 plus 0 is equal to 12, which is not divisible by 11. The number 5081 is also not divisible by 11. Page 57. Thus, to check the divisibility of a number by 11, the rule is find the difference between the sum of the digits at odd places from the right and the sum of the digits at even places from the right of the number. If the difference is either 0 or divisible by 11, then the number is divisible by 11.